dear grade 6 children, today we are going to learn the 7th lesson of the science textbook, that is magnets. So you all use magnets in our day-to-day lives. There are so many instances that we use magnets. Some of you use magnets in the toys that you are playing with. And under this lesson, we are going to learn a lot of information about magnets. So let's see what are the topics that we are going to learn under this lesson. These are the topics we are going to learn under this lesson, children. Effects of magnets. We are going to learn how magnets behave, what are the different effects of magnets, right? And different types of magnets. There we are going to learn different types of magnets are there. So those different types of magnets, according to their shape and according to their use, there are different types of magnets. And we are going to learn about magnetic poles. Now this is something new for y'all. So we are going to learn that there are two poles of magnets and they behave in different ways. And then we are going to learn about the behavior of a magnet. And then interactions between the poles of magnets. We are going to learn there are two poles of the magnet, and as I told you, they are different from each other. Therefore, the interactions between poles of different magnets we are going to learn. And finally, we are going to learn about magnetic forces. Understand, children? So under this lesson, apart from studying about these topics, we have to do a lot of activities as well. So let's get started. So first of all, we have to test the magnetic effect. Now I told you that magnets have different effects on other objects. So under this activity, we are going to learn about that magnetic effect. So what do we have to do here? What are the things we need to do this activity? Remember, you all can do this activity at home. Okay? So we need a glass of water. We need a glass of water and we need a file clip and a small magnet. So you can take a magnet from, some of you have fridge magnets, some of you have magnetic toys. Okay? So you can remove a small magnet from one of those types of materials. Okay? So let's see that how to do this activity. First of all, we are going to write what we need. As I told you, glass of water, file clip, and you need a small magnet. How to do this activity? Let's see. Look at this, children. First of all, you have to put this file clip into the glass of water. And now how to take out this file clip? We are not going to spill this water out. We are not going to put our hands in. We are going to take this file clip out using a magnet. Understand, children? So we will write the steps of these things. First of all, we will mark this one. The diagram. This is the magnet. This is the file clip. Water. Water. Glass. File clip. And the magnet. Okay, children. So what is the first step? The first step is you have to put a file clip into glass of water, right? Let's write that one. Put a file clip into the glass of water. Glass of water. What is the second step? I told you, now you have to take out this file clip, but you cannot spill the water out, or you cannot put your hand in. Without doing any of those things, you have to use a magnet to take out this file clip. Let's write. Without putting your hand in, take out the file clip. Take out the file clip using the magnet. Right, children? So we have a glass of water. Put a file clip into the glass of water. That's the first step. And then, without putting your hand in, take out the file clip using the magnet. So in that way, we can easily observe the effect of magnets, okay? So let's do this activity now. Right, children. Now we are going to do the first activity of this lesson. Right, so what do you need to do this activity? I already explained y'all. We need a glass and we need some water and we need a file clip and a magnet. So what we have to do is, we have to check how to take out a file clip in a water glass. Okay, now let's say that now at the moment this glass is empty. You all can see that. So if the file clip is just there in the empty glass, you can easily take it out like this. But now I'm going to fill this glass with water. And now I'm going to put this file clip to the glass. Now how to take it out without spilling water or without putting your hand into this water glass? How is it possible? Now normally if you want to take it out, if we don't have a magnet, we have to either spill this water away or we have to put our hand or something else like a pencil or pen, and we have to take this file clip out. But now we have a magnet with us, so without doing any of those things, we can easily take out this file clip. I'll show you how. Watch carefully. Right now you all can see this file clip attracts to this magnet. So using the magnet, I can slowly take out this file clip. Can you all see that clearly? Right. Now you all can see the file clip came out with the magnet. So did I put my hand in or did I spill this water out? No. So without doing any of these things, I managed to take out this file clip just using this magnet. So how is this possible, children? This is because magnets can attract certain substances, some materials. So the file clip also one type of those materials. So the material that we use to make this file clip attracts to the magnets. So it's very clear that magnets attract different substances and we can use it in our day-to-day lives. Right, children? So we observed how to take out the file clip without putting our hand in. So we can simply use the magnet to take out the file clip. So shall we write the observation, children? Let's write. When the magnet is dragged along the surface of the glass, outer surface of the glass. The file clip also comes out with the magnet. Right. Observation is when the magnet is dragged along the outer surface of the glass, the file clip also comes out with the magnet. So what is the conclusion? Why is this possible, children? That is because now when you consider the file clip, it gets attracted towards the magnet. This is why magnet can easily take the file clip out. Okay, so without even putting our hand inside, when we use the magnet from outside the glass, we can easily take the file clip out. That is because the file clip gets attracted towards the magnet. Okay, children. So after doing this activity, it is very clear that magnets can attract certain substances. Okay, that is an effect of magnet. Okay, let's write. So conclusion, magnets have the ability to attract materials. Magnets have the ability to attract materials. This is the special ability of magnets. So why is it possible, children? Because of the substances that magnets are made of, right? So magnets are mostly made of substances like iron, cobalt, nickel, and because of the combination of those type of substances, magnets get this special ability to attract certain materials towards it. Because of this ability, we can use magnets in our day-to-day life. So many activities, in many instances, we can use magnets because magnets can attract many substances, many materials towards them. Okay, so let's see the next one. Look at this one. There are magnets in many things which we use in our day-to-day life. Look at these pictures. Only a few examples are given here. What are these examples, children? Look at this one. This is a chessboard. You must have seen some of these chessboards, not all the chessboards, but some of these chessboards are magnetic. So if you carefully observe the underside of these chess pieces, you will see a small magnet is there. Okay, so because of the presence of that magnet, when we use this chessboard, these chess pieces will not move here and there unnecessarily. Only if we move, these chess pieces can be moved. Otherwise, they will be nicely attracted towards the chessboard. Okay, children? What is this? This is a small motor, children. Sometimes in a lot of lab experiments, we have already used these type of motors in our different types of lab experiments. So inside the motor, even though we can't see, inside the motor, there's a small magnet present. Okay, children? So when the magnet rotates, electricity is generated by the motor. Okay? And then what is this? You must have seen these type of pencil cases, right? These type of pencil cases, they have the cover, the part that you have to close, the lid part has a small magnet connected. Okay, so you can easily close these type of boxes because of the presence of magnets. And at the same time, you must have seen sometimes certain bags, purses, bags also have these type of tiny magnetic buttons. Instead of using the zipper, we can use the magnetic button to close them easily. Right, children? Let's write these things. Chessboard, magnetic chessboard. And a small motor, pencil box, so there are other instances as well. So we are going to write the other instances of using the magnets in our next activity. Look at this assignment. Make a report of other instances where you can find magnets in day-to-day life. So we wrote 3 examples here in magnetic chessboards, in motors and pencil boxes, right? Other than these things, what are the other instances that we use magnets in our day-to-day lives in different instances? Let's see. Make a report. Now, when you make a report like this, you can get information from the internet, from the books, and you can ask your teachers as well. I will help you with some examples, but you have to do this as a complete report. Right, children? If you read a lot of materials, if you check the internet, you will find a lot of examples for the uses of magnets, instances where we use the magnets. Okay, children? So what are the other instances, children? So you must have seen, as I told you before, some toys have magnets in them. Have you seen these certain building blocks with magnets? So when you keep them together, they instantly attract towards each other. So you can easily build them up. Okay, so let's write down some toys. Example building blocks. Magnetic building blocks. What else, children? So the second instance is in day-to-day life we use. When we use the refrigerator, we use the magnets. That is because the fridge door has a magnetic effect in it, right? That is because the fridge door should nicely fix to the fridge when we close it. That is, otherwise it will disturb the cooling process. Okay, children? And at the same time, you must have seen in the fridge magnets also, small magnet is fixed. We'll write that example as well. Fridge door and fridge magnets. Fridge door and fridge magnets. And sometimes certain whiteboards also there. Some whiteboards are magnetic. So sometimes teachers have to show different charts to the children. So using small magnets, teachers can easily fix these charts onto the whiteboard. So that is because some of these whiteboards are magnetic. Let's write that as well. Some whiteboards. Some whiteboards. What are the other examples, children? As I told you before, in some bags, magnetic buttons are there. Instead of zippers, sometimes magnetic buttons are there, right? In some bags, magnetic buttons present. Okay, so we wrote about pencil cases. What are the other instances, children? Sometimes some jewelry pieces you must have seen. Some of you must have seen sometimes magnetic earrings are there. So without pierce in your ears, you can simply put these magnetic earrings. Okay, so in some jewelry. And sometimes magnets are used in medical field as well. Have you heard of MRI machines? MRI machines are used to check the internal parts of your body. So in the MRI machines, a strong magnetic field is used. Okay, so let's write that as well. In MRI machines. MRI machines. Okay. So these are only some examples, children. So if you look at your own environment, if you ask your teachers, so if you read book and if you check the internet, you will find so many other examples as well. So as I told you before, remember when you make this report, you have to make it as a complete report, not only a few examples. Take your time and look through the sources and you can find many other examples as well, right? Now, effects of magnets. The next topic is effects of magnets. We have to do this activity. Observing the effect created by magnets on other materials. Now we already know the magnets have an effect on the other materials. That is because magnets can attract materials towards them. Can magnets attract just any material, children? By doing this activity, we are going to check whether the magnets can attract any materials or not. Okay? So look at this activity. What are the things we need to do this activity? Look at this list carefully. We need a magnet. We can use any type of magnet here. And we need to use an iron nail, a brass nail, we need a copper wire, we need a piece of aluminium sheet, we need a coin, a piece of plastic, a piece of wood, a piece of paper, and a needle, right? Let's write these things first. Magnet. We need one iron nail. Let's write iron nail. And a brass nail. We need a piece of copper wire. And we need an aluminium sheet. Aluminium sheet. We need a coin. A piece of plastic. A piece of wood. Piece of paper. And a needle. A magnet, iron nail, brass nail, copper wire, aluminium sheet, a coin, a piece of plastic, a piece of wood, a piece of paper, and a needle. So how to do this activity? It's very easy. You just have to hold this magnet over each of these materials and check whether they get attracted towards the magnet. Okay, children? So let's go to the method. So the method is keep each of the above items near the magnet and observe the changes. Now we already know some of these materials get attracted towards the magnets. After doing this activity, when you know that how we use the magnet to take out this file clip out of the glass of water. So we know that file clip gets easily attracted towards a magnet. We are going to do the same activity, same type of activity with different types of materials. Let's do this activity in the laboratory now. Right, children. Now we are going to observe the effect of magnets on other materials, so other objects. Now I already explained you all how to do this activity. So what do we need to do this activity, children? Look at the table, children. Now I have many things on the table. Now here I have a magnet. This is a U-shaped magnet, children, right? And here I have an iron nail, a brass nail, a copper wire, aluminium sheet, and I have two coins here, one 5 rupee coin and 2 rupee coin as well. And plastic pen cap I have, and a piece of wood, a piece of paper, and a needle. So as I explained you all, what am I going to do? I am going to hold this magnet over each object and I am going to check whether these objects get attracted to this magnet or not. Okay, let's start with the iron nail. What happened, children? The iron nail easily gets attracted to the magnet, right? What about the brass nail? The brass nail, unlike the iron nail, brass nail does not get attracted to the magnet. Copper wire, right, you all can see copper wire also, like you can see that copper wire also doesn't get attracted to the magnet. Aluminium sheet, again there's no attraction, children. You all can see clearly, no matter how many times I hold it over, it does not get attracted to the magnet. Now we have two coins. First of all, I am going to hold this magnet over the 5 rupee coin. Can you see any attraction? The 5 rupee coin does not get attracted to the magnet. We'll check with 2 rupee coin. Now, 2 rupee coin gets attracted to the magnet instantly. So this happens because 5 rupee coin and 2 rupee coins are made out of 2 different materials, okay? Plastic pen cap. Again, there's no attraction. You all can see there's no attraction with the plastic pen cap. What about the piece of wood? No attraction again. So piece of wood also does not get attracted to the magnet. Paper. Right, paper also does not get attracted to the magnet. And finally, we have the needle. So you saw the needle instantly get attracted to the magnet. See. So the needle easily gets attracted to the magnet. Right. So after doing this activity, one thing is clear. Some of these substances, so the materials, get attracted to the magnets and some of them do not get attracted to the magnet, okay? So we'll separate them into 2 groups now. So the iron nail gets attracted to the magnet. I will keep them here. Brass nail, no attraction. Copper wire also no attraction. Aluminium sheet, no attraction. 5 rupee coin, no attraction. But 2 rupee coin gets attracted. I will leave it here. Plastic pen cap does not get attracted. Wood or even paper don't attract. And the needle easily gets attracted to the magnet. Right? So the iron nail, 2 rupee coin, and the needle get attracted to the magnet. The brass nail, copper wire, aluminium sheet, 5 rupee coin, the plastic pen cap, the piece of wood and the piece of paper, they all don't get attracted to the magnet. So after doing this activity, it's very clear that there are some materials or some objects, they easily get attracted to the magnets, and some other materials are there, they don't get attracted to the magnet. So the observations were very clear. I hope you all watched the experiment and how each material reacted with the magnets, okay? So what are the observations? Things which got attracted towards the magnet, things which did not get attracted towards the magnet. So when I was doing the experiment, I hope it was clear that some materials easily get attracted towards the magnet. But some other materials, they did not get attracted towards the magnets. So we are going to group them into these 2 groups. Things which got attracted towards the magnet and the things which did not get attracted towards the magnet. First of all, we'll go through the list. Here we used with a magnet, iron nail, brass nail, copper wire, aluminium sheet, coin. Do you remember I showed you 2 coins in the experiment? During the experiment, I used 2 coins. Okay? Piece of plastic, piece of wood, piece of paper and a needle. Do you remember what are the materials that got attracted towards the magnet? Right? Do you remember the iron nail? Iron nail got attracted towards the magnet. Right? What about the brass nail? It did not get attracted towards the magnet. Copper wire and aluminium sheet also did not get attracted towards the magnet. What about the coin? Do you remember one of the coins I used got attracted towards the magnet and the other one did not get attracted towards the magnet? What about the plastic, wood and paper? They all did not get attracted towards the magnet. And finally, the needle got attracted towards the magnet. So we can group them in the table I showed you before. Things which got attracted towards the magnet. We will write here iron nail. So there were 2 coins. We can't write because only one got attracted towards the magnet. Therefore, we will write some coins. and the needle. What are the things that did not get attracted towards the magnet? Let's write brass nail, copper wire, aluminium sheets, and because another coin did not get attracted towards a magnet, we can write, even under this one, we can write some coins. Right? In short form, we will write some coins get attracted towards the magnets and some other coins don't get attracted towards the magnet. Right? So here also we can write some coins. Plastic, wood, and paper. So what are among the list that we got, among the materials we got, what are the things which got attracted towards the magnet? Iron nail, some coins, needle. And what are the things which did not get attracted towards the magnet, children? Brass nail, copper wire, aluminium sheet, some coins, piece of plastic, piece of wood and piece of paper. Okay, so these are the things that did not get attracted towards the magnet. So what is the conclusion, children? What do we have to write under the conclusion? What we can decide, what is the decision that we can come up after doing our experiment? What is the conclusion, children? So after doing this activity, I hope it's very clear that only some materials get attracted towards the magnet, but some other materials are there, they don't get attracted towards the magnets. Let's write the conclusion. Some materials attracted towards magnets, while some other materials do not get attracted towards magnets. Some materials get attracted towards magnets, while some other materials do not get attracted towards magnets. So after doing this activity, this is very clear. Only some materials get attracted towards the magnets, but some other materials are there, they don't get attracted towards the magnets. We have an assignment to do. You all have to do this assignment at home, okay? You all can do this activity very, very easily. Let's see. Take a magnet to your compound and find out the things that get attracted to it. So if your compound has a gravel floor or sandy floor, you can easily do this activity, okay? So what you have to do, if the soil is very tight, you can dig a small place and you can put a magnet inside, okay? So let's say you can put a magnet inside and move it here and there. If this is soil, take a magnet and insert it to the soil present area and you have to move it here and there. Most of the time you wouldn't be able to observe many things get attracted to the magnets, but sometimes, children, you will see tiny parts, tiny pieces of substances will get attracted towards the magnet. What is the reason? There are a lot of minerals, different materials are mixed with soil. This is why if you observe carefully, sometimes you will be able to see tiny particles attracted towards the magnet. If you have piles of soil, this activity is very easy. Let's say that if you live near construction areas, you will be easily able to find out these type of piles of soil. So in that case, these type of soils, if you use the magnet and if you put the magnet inside the soil and move here and there, sometimes you will be able to find more materials get attracted. Okay, children? So by doing this activity, you can understand that even in the environment, even in the natural environment, there are certain parts, certain materials that get attracted towards magnets. Okay, children? Now we are going to learn about the different types of magnets. Remember, at the beginning of the lesson, I told you there are different types of magnets based on their shape, based on their use as well. Okay? The magnets differ from each other due to their shapes. Now look at these magnets. These are some examples. There are many other examples as well. Also, they are used for different purposes. Okay? So what is this one? This is known as the horseshoe magnet. Look at the shape. This is the shape of a horseshoe. This is the most widely used magnet even in the school labs. These type of magnets are widely used. This is known as the bar magnet. Look at this one. This is known as the U magnet because of its shape. Shape is like U. What is the difference between this U magnet and horseshoe magnet? They both look the same, but look at these two ends. The two ends of the horseshoe magnet is more moved towards each other than the U-shaped magnet. Okay? Look at this one. These type of magnets are known as ring magnets. What is this magnet? These are known as tabular magnets or button magnets. Okay, children. Let's write their names. Horseshoe magnet, bar magnet, U magnet or U-shaped magnet. Ring magnet, this is known as, there are different names. Let's write all. Tabular magnet, tabular magnet. Other names, button magnet, disc magnet, so these are, as I told you before, these are only some magnets. There are other shapes as well. Now we will go to the lab and see some of these type of magnets. Right, children. Now I'm going to show you different types of magnets. Look at this table, children. Can you all see there are a number of magnets here? Look at this first magnet. This is known as the horseshoe magnet, children. That is because the shape of the magnet is like a horseshoe. Okay, this is a horseshoe magnet. So you can see this red side is the north and south is the blue side. Okay, so when you take the magnet, you are going to learn in the other experiments as well. There are two sides, north and south poles. Okay, this is very commonly used for our experiment and this is known as the bar magnet. Okay, according to the shape, it gets its name, the bar magnet. Okay, so here also you can see the red north pole and blue south pole. Okay. And look at this magnet. This is called the U magnet because the shape is like the letter U. So can you see the difference between these two? It almost looks the same, but the shape is slightly different, right? So this is called the U magnet. And these type of magnets are known as ring magnets, because of which shape it gets the name, like a ring. So these magnets, the other magnets, you can see north and south poles clearly marked. What about these type of ring magnets, children? The either side of the magnet, up and down side, it has north pole and south pole. Okay? Right. So look at this magnet, children. This is known as the ball-ended magnets. That is because in the either side of the magnet, two ball-like structures are connected. That is why it is known as the ball-ended magnet. Okay? Right. So these are only some of the magnets, children. But there are other shapes as well. Other dumbbell-shaped magnets are there. Oval-shaped magnets are there. So you will experience, if you look at different types of objects, you will see different types of other magnets as well. So you saw some magnets. These type of magnets I showed you all, right? So here it's mentioned they are used for different purposes. Yes, in day-to-day lives, these different types of magnets, different shaped magnets are used for different purposes. Okay. So these type of horseshoe magnets or even sometimes U magnets are used to separate materials. Okay, separate magnetic materials. Sometimes in junkyards, these type of magnets are used to separate certain materials. Okay. Bar magnets are used in laboratory experiments, and even in the compass, a small bar magnet type magnet is used. Okay, a flat one. And these tabular magnets or button magnets, sometimes they are used in clothing and sometimes to make jewelry. Some of you must have seen these type of tabular magnets used in toys, like those underside of the chess pieces in magnetic chessboards. Also, these type of tabular magnets are used. What else, children? Sometimes these type of magnets are also used in fridge magnets as well, right? So the fridge magnets, it depends on the shape of that certain structure. Sometimes even bar magnets also used in fridge magnets. Okay, children, so these are only some shapes and some uses of magnets. Okay, so you can read different articles and you can ask your teachers. There are many other instances where we use different other shapes of magnets as well. Okay, assignment. Collect some magnets from equipment where magnets are used or discarded and categorize them according to their shapes. Now, this activity actually takes a certain time period because you can't collect these type of magnets within a very short period of time. But it's very interesting to collect these type of magnets, isn't it, children? That is because you can observe what are the different shapes, what are the different instances we use, different types of other magnets as well. So here we learned only some of these magnets. And we can learn what are the other different shapes of magnets. Okay. Sometimes in certain bookshops, they sell these sets of magnets. Okay. So they have different in those sets of magnets. Sometimes there are different other shapes of magnets also there. Spherical shape or sphere magnets are there. Sometimes cylindrical shape magnets are there. Right. We will draw some of them. Some examples. Cylindrical magnets. I'll show you. These type of cylindrical magnets are there. Let's write the name. Cylindrical magnet. Sometimes spherical magnets are there. These are known as sphere magnets. Bowl shaped, right? Oval shaped magnets are there. Oval magnets. And do you remember in the lab I showed you ball-ended magnets? We'll draw that one as well. So two circular parts like this and ball-like structures at the end like this. Remember, children? These are known as ball-ended magnets. Okay, so these are other instances. So if you look at other instruments, sometimes you will be able to find these type of magnets as well. Okay, so based on the purpose, the shape of the magnet is also different. Understand, children? So we have completed the first chapter of this lesson. Do you remember what we learned here, children? We learn about effects of magnets and we learn different types of magnets based on their shape. Okay, so I hope you understood this part very clear. Now we are going to start the second chapter.